Okay, so okay, recorded already. Okay, sorry for the late. Okay, I overlooked the schedules. Okay, so okay, so this is the mock lah. If you have anything, please do ask me. Okay, if you can open your mic and ask the best lah, because I'm not. Sometimes I've really did not see look on the chat room lah. Okay, so please ask me if you have any question lah. Okay, so else I'll continuing. I rarely look on the chat. Okay, anyway, so just go on lah. Okay, this is the first questions. Before I start, okay, I just remind you again. Okay, the syllabus of the exam is on chapter topic 2, 3, 4, 5, 6, which means topic 2 to 6. Okay, let me write here, 2 to 6, and then 8 to 10. Okay, so these are the topic. 2 is what I call it, manometer. 3 is the what I call it, a hydrostatic force. Okay, hydrostatic force, the incline, got curved surface, got vertical, got horizontal. Chapter 4 is continuity equation. 5 is Bernoulli equation. 6 is momentum. 7 no. 8 and 9 is Buckingham or dimensionless. Okay, Buckingham. 10 is head loss. Okay, so these are the topics and the main content. Okay, so again, if you do not know what to study, of course, make sure you know how to do the tutorial. Okay, so that's all. I mean, this is some I call it some information for you to know. Okay, about the exams. So also the exam is 3 hours. Okay, there will be 6 questions. Of course, some of the questions will have A, B, C, something like that. Okay, have a sub question. We call it. Okay, so we look on the first questions. First question is I would say quite easy. Okay, so you can see water flow from a large tank through a branch pipe which discharge as a flow free jets. Okay, free jets, which means they will flow out. Okay, both of the pipe point 2 and 3 are exposed to the atmospheric pressures. So first of all, give 2 assumptions for Bernoulli equations. So you have five we call it condition. Okay, assumption. You have got 5. One is no friction. Okay, frictional loss is frictional is negligible. Second one, no external energy. The third one is streamline. And then no heat, no heater and pump. And then one more, I can't remember. Okay, so but this question only requires 2 lah. Okay, so please look for the 5th one. I remember it will have 5. And then now only we go to the calculation part. So in these questions, we will use the continuity as well as Bernoulli equations. Okay, so this is how the question will be looks like similar to your final exams. So especially for chapter 4, 5, and 6. So they are most likely they will combine. Okay, then manometer, they might come out individually or they might come out in Bernoulli equation questions, or they might come out in the head loss questions. For hydrostatic force, it will always come out itself. For chapter 8 and 9, they will always come out together 8 and 9 as a questions. Will the Buckingham come out with Bernoulli equation? No. Okay, so this is how it come out lah. Okay, so anyway, we come to here. So they ask the pressure at 1. So here. So you have diameter. Okay, you have all diameters. So what the first thing that you need to do is you have to find your A1, A2, A3. Because finding all of this will give you marks. So remember is pi r square or pi d square over 4. No matter which one you are using, you have to make it as meter. So let's say pi 0.025 meter. Okay, bring it down first. Oops. Okay, so by calculate, so you will get pi square. So you will get 0.001963 meter square. A2, I'm not going to rewrite, okay, but I write this D2 okay, 0.015 square. So you will get 0.000760669 the square. And A3 similarly 0.000314 meter square. Okay, so after you found this, then only you talk. Okay, you see what you have. Okay, then of course for this case you will do Bernoulli equations. Okay, why? Okay, I will compare Bernoulli equations between point where you want to find point 1. Okay, point 1 cannot. Okay, let's say point 3 and point 4. Why? Okay, of course, if you do not know, you can list out everything, all the information that you know. Okay, so because in order for you to use Bernoulli equation, you have to find all of them, all these three, all of these things. For 3, because it's a free jet, is 0. Pressure 4 is water surface, 0. Velocity of the surface, 0. Velocity 3, I don't know. This is I'm looking for. Height 3, 0. Height 4, 7. Why? Because you have 7 meter height. So height is calculated from bottom. Okay, this one you have to remember. So therefore you use Bernoulli equations. Okay, again, just writing out the formula. Okay, square 2g plus z4. So then you will find that P4 is 0, P3 is 0, Z3 is 0, P3 is 0. So V23 2g equal to Z4. So Z3 square, Z4 is 7 times 2 times 9.81. And then you get V3 is and then V3 equals to 11.372 meter per second. So this is how you find V3. Okay, so so why you need to find that? Because you are not able to find the pressure at first place. Okay, so then you use they want okay. Then only you use Q what Q. Okay, so before that you have to find for the part 2 first. Bernoulli equations. I use another color. Bernoulli equations between 2 and 4. So 4 I already have, so I don't need, but P2 equal to 0 because again this is free jet. Okay, so then velocity 2 I'm looking for. Height wise it is 4 meters, so 4. So if you write the Bernoulli equation again, sorry, not 3, 2. You should write it. 4. If you want to compare with 3, also can. So here 0, 0, and then P2 is 0. So that's why you have V2 2G plus 4 equals to 7. So basically your V2 will be square root 3 because 7 minus 4 is 3. Then 2, 9.81. So you will get V2 is 7.6. So after this, what to do? Okay, you have to find the flow rate. Q3 equals to A3 V3. So you get it lah. Okay, here and here. Okay, but I did not rewrite. I just straight away to the answer. So you get 0.00368 meter cube per second. Q2 equals to 7.67 times 0.0006. So 0.0014. So Q1 equals to Q2 plus Q3. So A1 V1 equals to 0.00368 plus 0.0054. So you will get 0.0091 and V1 equals to 0.0091 divided by 0.001963. So you get your velocity. Okay, why I want to get the velocity? Got space or not? No space. All right. Yes, good. So because now I would like to compare BE between 1 and 4. Again, you can compare with 3, can compare with 2 also, up to you. So, but, okay, P1 equals to, I don't know, V1 is 4.637, height 1 is 0. So when you write the formula, okay, for Bernoulli formula, V1 square, height 1, 4. Height 4. Again, this is 0, this is 0, height 1 is 0. So P1 over gamma plus 4.637 square over 2G equals to 7. So then P equals to gamma with 7 minus 4.6 square over 2, 9.81. So then you do lah. 4.637 square divided by 7 minus answer times gamma is 9810. So then your P1 is 57.9 kilopascal. That's it. Okay. So since although you are looking for this, but they are also asking for flow rate. So flow rate 3, flow rate 2, flow rate 1. That's why you answer everything. Okay, so any question for this? Okay, so they are using what I call it, continuity equation as well as the Bernoulli equations. So you are free to compare any point as long as they are streamlined, as long as you have the values. Okay, you can compare 2 to 4, 2 to 3 because you started with 3 to 4. Okay, that's why you have information of 3 and 4. Then when you compare 1 and 4, you can compare to 2 and 1 and 2, 1 and 3, or even 1 and 4, up to you. Okay, provided you have all the informations. Okay, so any questions? Okay, so if you doesn't have any question, then I assume that you understand. Okay, so I'll go to the next questions. Um, okay, so this is the next question. So this question is your hydrostatic force. Okay, you can see first you have a dam with 5 meter. Okay, so and a height of 9 meter, so as shown. So determine the hydrostatic force exerted on the dam side, okay, and the depth of the center. Okay, which means the what you call it, the location and the force. So first of all, 7.5 is the water height. 9 is the dam, the building height. So the pressure or the force will be due to the fluid, not due to the 9. So that's why your HC, because vertical plane, it always half. So you have to use half. So how much? 3.75. Area 7.5 times 5. You cannot use 9 because this is the area. The area is not talking about the building area. It's talking about the area that exerting the vertical force or exerting the hydrostatic force. So then you will get 37.5. So FR equals to rho GHCA. I see a lot of students using rho GH. That is for pressure. We are looking for force. So it has to be rho GHCA. So, and E is a water. Okay, unless stated. HC 3.75 and 37.5. So then, okay, this is 120479 Newton. Okay, or 24689. Above 9 Newton. That's it. Location wise, okay, you see, HC is divided by 2, YC is 1/3. Okay, which is 2.5, and I have to bracket from bottom because 2.5 can be from the top, which is here, but the real one is here, 2.5 from bottom. That's why you must specify very, very clearly. Okay, so this is second questions. Okay, any questions? Okay, if no, then I'll go to next. Okay, this is the Buckingham. Okay, some of your friends doing this on the assignment actually not doing quite well. Okay, remember you must show everything, all the steps. All the steps including the first step, okay, providing the function. Okay, so for this case, function is, okay, I would say, they say what? Okay, drag force is a function of V, area, density, and then drag force. Okay, okay, drag. Okay, so then the second step is you have to make every one, 2, 3, 4, 5. F, D, V, A, C, D. Okay, so F is Newton. Okay, F equals to MA lah. So kg mass, acceleration, FO, F MA, length over T square. Okay, velocity, distance over time. A is the area. Area is length square. Density is meter cube. Okay, kg per meter cube. Mass over length cube. Coefficient. This one I don't know. Okay, coefficient of drag. Let me check. Unit. Oh, okay. Drag is a unit. What I call it, dimensionless. So it is 1. Okay, so this is a second step. Okay, I show you step 1, step 2, step 3. Step 3 is what? So K minus R. So K is what? K is how many variables you have. 1, 2, 3, 4, 5. So 5. R is, are you using M, R, M, L, and T? So if you have used, you see M, L, and T shown. So 3. So is 2. 2 means, okay, you must give 3 repeating variable, 2 non-repeating variables. The first non-repeating variable must be FD. The 3 repeating variable will be V, A, density. Why? A is under geometry. V is under kinematic. Rho is under fluid properties. Can I pick CD? No, because it is a dimensionless. Okay, so it will be a CD. Okay, so after that, okay, then only you, once you pick already, then you go number 5. You do pi 1 equals to FD, the first non-repeating variable, followed by all repeating variables. A, B, C equals to MLT 0, 0, 0. So next, you convert everything. M, L, T square, L over T, A, L square, B, M, L, 3, C equals to MLT. Start with what? Up to you lah. Okay, start with M. For M, MC equals to M0. So M1 plus C equals to M0, 1 plus C equals to 0, C equals to -1. Then we go for L. L you have 1, which is here. I shortcut already, plus A, you have 1 already. Then you plus B, sorry, you have 2B. Then you plus C equals to 0. But you cannot find it first. Then you go for T. T is -2 minus A minus 3C equals to 0. Okay, if you do not know how to do this in shortcut, you come back here using the original slowly steps. So in here, I have -1 as C. So then it becomes -3. So -A equals to +1. So A equals to 1. So now I have A equals to 1 minus 1. So 1 minus 1 gone. So negative is -1. B is -½ So in other words, my pi1 will be FD V1 A -½ density negative. So all it will be FDV over square root A density. Okay, then you conduct for the second one. Okay, second part. I do. Okay, I try to finish by this small space. CD VA density ABC equals to MLT. So you convert everything. So same lah. 1 L over TA L square B M over LC 3 equals to MLT. So everyone has to bracket okay, in case, okay, because this is not the unit, this is the symbols. So basically then you will get pi2 is CD lah. So therefore you will get your answer as pi1 is what? FdV over square root A density equals to theta bracket CD like this. Okay, so this is your dimensionless. Okay, then this is the part doing this. Okay, then we goes in. What will be the drag force if the density change, if the area change? Okay, so now the first part is density increase 3 times. So you have this. So, okay, if density increase 3 times, okay, so what happens? Okay, so your density, your drag force will be increased 3 times. Okay, or I do in a we call it proper way. Okay, no. A1 equals to A2 not A pula. V1 equals to V2 density 1 increase 3 times. Density 2 is 3 times of the density 1. So FD1 V1 okay 1 equals to FD2 V2 A2 density 2. So since A1 V1 the same value, so cut off. But Okay, FD1 over density 1 equals to FD2, 3 density 1, density 1, density 1. So therefore, 3FD1 equals to FD2. That's why for this case, if you increase the density 3 times, you will increase the force 3 times. You are doing the same for the second one, but due to the lack of space, I did not do, but you are doing the same thing, same as what I did. This is called similitude. Okay, pi 1 equals to pi 1. Can you use pi 1 and pi 2? Cannot. Must be pi 1 to pi 1 or pi 2 pi 2. It depends on what you are looking for. But you surely cannot do pi 1, pi 2. Okay, I see your chat. There will be a buoyancy force question. Yes, it could be. Okay, it could be buoyancy force. So like your tutorial, yes. Okay, then number 4. Okay, so what is this? Okay, this is a head loss lah. Okay, so you can see for you are working as an engineer to analyze the new piping systems. Okay, where you have a kinematic viscosity that raise 5.7 cm water. Okay, and the total length of the 3 cm diameter pipe is a 53 cms. So it tried to minimize the pressure needed lah. Okay, which means minimize the heat loss lah. So construct the control volume, inlet and outlet. So of course this is inlet, this is outlet. Control volume is like this. That's it. Okay, so control volume is the part that you are considering lah. Okay, so it's not the system, you see. Then calculate the pressure due to the major loss. For now, you are neglecting the minor loss first. Okay, in order to do the major losses, HL equals to F L over D V square over 2G. In order to find F, the first step is to do Reynolds number. For Reynolds number, the formula is V velocity. Okay, I can't really remember the formula. Hold on, let me find the formula sheet. Formula sheet. Let me find out the formula sheet first. Okay. I download from here. Okay, so here's the formula sheet. Reynolds number, Reynolds number, Reynolds number. Here. Okay. Density D over kinematic viscosity. Okay, so or VD over kinematic viscosity. So remember, kinematic viscosity is dynamic viscosity divided by density. Okay, so from here, okay, so I have dynamic viscosity. Right, I have a kinematic viscosity. I have a diameter, but I doesn't have velocity. Okay, so this also a previous question for previous batch students. A lot of students, they just ignore the missing of the velocity. They just use the V as the velocity as well as for the kinematic viscosity. Okay, but of course this is wrong. So how you find? You will need to find from here. Okay, so why? Okay, let me draw. This is the outlet. Okay, so then you will go 5.7 cm. Right. So in here, there will be certain velocity, let's say 2 lah. And this velocity are the velocity for all piping. Okay. Okay, I should draw it this way. Then this is 10 here. So then after it goes up, okay, because for this piping, before they goes up, they are in the same, what you call it, same level. Okay, when they are in same level, okay, and the pressure did not change, the velocity will be the same. So V2. So at V2 in here, V3 equals to 0 at highest point. Okay, because kinetic energy goes to potential energy. So you can use mgh equals to 1 over 2 at k mv squared. Momentum, not momentum, potential energy to kinetic energy, or you can use, let me think, P here and here. Okay, no, you have to use this lah. Okay, so I believe still got others. Okay, N and M clause. So 9.81. H is 10 plus 5.7 cm divided by 100 because I want it into the meter, equals to half of the V square. So then you will get 50.7 times 9.81 times 2 square root. So your V is 1.7555 meter per second at here. So then I can do it. 1.7555. Diameter is 3 cm, so 0.03. Viscosity value is 1.12. Okay, so times. Okay, then you get 47,000, which is definitely turbulent. So when you are a turbulent, your F have to find from the value. Okay, so this is the table that you will see. 47,000, which means 4.6 times 10 power of 7. 4, sorry. So this is 1 times 10 power 4, 2 times 10 power 4, then 3 times 10 power 4, 4 times 10 power 4, 5 times 10 power 4, so 4.5 here, 4.7 is roughly here. So that's why you will have something here. Sorry. Somewhere here. Then you go back to the material. They are using cast iron. In here, cast iron is 0.26 mm. Diameter is 3 cm. So, or equivalent to 30 mm. It's okay for you to convert both into meter or any, because as long as they are in same unit, that would be fine. Because what you need is this one. So then you will get 0.00867. 0.00867 is 20. 20 is here. Roughly here. Okay, so then you will proceed according to the curvature of the line. If it start to go up, then it goes up. So after you meet the vertical line there, then you proceed. Okay, I will use here. Then you go here. So here is 0.03, 0.04, 32, 34, 336, around 0.037. So therefore, your F is 0.037. Okay, so this is how you find. For lengthwise, they already mentioned 53 cm, 0.53. Diameter wise, 0.03, we got 3 cm. Velocity, I got already 1.7555 g. Okay, therefore I can find my HL. (1.7555) square over 2, 9.81. 0.037 times 0.35, 1.7555 divided by 2. So you will get 0.1026 meter. Okay. So then for C, okay, you suggest a new system with using galvanized iron. Then everything will be the same, except how to find your F will be different because now your F will be, it's using galvanized iron. So it will be 0.15 divided by 30. So you will, 0.15 divided by 30, 0.005. So 0.05 is around is here lah. Okay. So again, you will go and according here, and then you will go roughly this way. So it will be 0.032. So then your new F 0.032 with the rest value are the same. Then you manage to reduce down. And then you find the percentage. So this is how you find. So the most importantly is you have to know how to use this table. Of course lah. For formula wise, all formula given. Okay, just that you need to know how to which one to use, how to use it. Okay, but the table again given. Okay, as shown as this one. Just that you need to know how to use it. Okay, so any questions? Okay, so I go to the last questions. So this question actually is the question from your tutorial. Okay, so but I just quickly go through again. So basically, okay, so the question is the gasoline at 20 degrees Celsius at 12 meter per second in a 5 cm diameter. So this is 5 cm diameter or given already. So they encounter a meter length of the uniform radial wall suction, which means there will be the liquid will goes out this way with 10 equal size hole, which means here, okay, if I draw the 3D, okay, so there will be 10 hole, okay, 10 hole lah, okay, on this 1 meter length. So after the suction, it become this one. So they ask you to calculate mass flow rate and volume flow rate for 3 points. I mean 1, 2, and 3. So 1, 2, and 3, 1, 2, and going out is 3. Okay, so before, Q1 equals to Q2 plus Q3. So Q1 is A1 V1. Again, diameter pi 5 cm to 5. And velocity is 12. Alright, again, area pi square times 12. So you will get 0.02356 meter cube per second. Then Q2, correct. You do the same thing. then you will get 0.01963. For Q3 is Q1 minus Q2. So you will get 2356 minus 0.1963, 0.00393 meter cube per second. Okay, so therefore, of course, for mass flow rate, everything you times the density of the fluids, which is 680. Then the second one, okay, looking for the diameter of the suction hole. So now Q3 is the volume flow rate for those suction hole, and if you have 10, so each of them will be 0.0003 meter cube per second. Okay, so then it is area times velocity. So V3 is 8 meter. So which means pi r square times 8. So that's why your R will be 0.00395. And your diameter will be 0.079 meter. Okay, so that's it. Divide diameter. For C, okay, so P1, P2, okay, estimate the thrust force. Okay, so force is F equals to m dot V1, V2 minus m dot V1. Okay, for m dot, later on you can calculate. V2 is 10 because we are looking for x-axis only. Okay, V2 is 10, V1 is 12. For force, okay, force wise, okay, the movable part is the tube itself. So we will use minus R, then P1A1 minus P2A2. So which means that you will have 100 kilopascal times A minus 80 kilopascal A2 minus R rho AV. Okay, rho AV is 0.02356 times 680 times negative 2. Okay, so then you will get, okay, 40,000 times area minus R minus 3.2. So area is this one, the same thing. So you get 78.5 minus R equals to negative 3.2. So R equals to 81.74 kilopascal. Okay, so this is your thrust force. While the D, okay, because okay, they just want to show why there's no thrust force in the vertical. So therefore, you just need to explain. Okay, perhaps I mean, for example, okay, because okay, the thrust upwards equals to thrust downwards. That's it. Okay, not really need to calculate. Okay, that's why they ask you to show only. You can show in drawing, in whatever method. Okay, so any questions? Why negative R? Okay, so first, because the water pushed that side, okay, there will what you call it, the pipe itself will move this way. So this way is negative directions. Okay, because I trade moving to the right hand side is positive. That's why moving to the left hand side is positive. Oh, sorry, negative another way lang. Okay, so any questions? Okay, it seems everyone is fine. It's good.
So the one that you sent still got extra 2 more questions. 5 and 6 is like manometer and the pipe flow. The one you send in my times. The first 4 question is the same, but then the got 5 and 6 is different.
Oh, really? Yeah, I share wrongly. Yeah, because this is from the my time. Sorry, from the group one. Uh, the one I need to check. You ask me later on, then I will consult you personally. Because I need time find that one because I don't know where I put already that one. Okay, the exam will be similar. I would say almost similar lah. At
Similar
least the
to this one or
difficulty. Sorry.
similar to this one or the my times that one?
Actually, both are the
As
same.
well.
Both are the similar difficulty. So that's why in 6 questions, like I said just now, but there will be sub questions there. A and B, something like that, and then 1, 2, 3, asking for like you see in the mock question lah. You got A, B, C, D, something like that. Okay. I think that's all lah. Okay. So yeah.
Sir.
Yep.
For the mock questions you gave, right? Could you give like the workings or answers just in case?
Again.
The questions that you didn't discuss here, like the other guy said.
You share me your working.
Okay. All right.
Comment.
Okay. All right. Thank you, sir.
Okay, I will not send this file. If you want to look everything, I will share the recording video and then you check it again and again. I don't want you to just look on the solution. You check the video. I will share you later.
All right, thank you a lot, sir.
Okay, thank you. Okay. All right, so that's all. Okay, thank you. Thank you, everyone. I will share later. Okay, thank you.
All right, thank you, sir.